the webinar series, which is past, present, and future, the global pandemic in relation to India, the COVID-19 situation. And we have with us Anjeli Kumari Ilieva, who is working at Bonalev, and she's passionate about healthcare innovations, blockchain technology, and fighting microbial resistance. So she's from Finland, and today she's here to give us a talk on antibiotics resistance, and she would be also talking about the mental health. About is that true, Anjeli? This is what you're talking about in COVID-19?
Yes, yeah. I will shortly cover mental health in the end.
Yeah. So over to Anjeli. She's from Finland. She's from Turku. She had her basic education from Turku and Finland, and she has spent a very precious time to be with us. We are so thankful to you, Anjeli, for accepting our invitation. So
it's my pleasure.
It's all yours now.
Thank you very much, and thank you so much for inviting me. It's actually my first webinar during Corona, COVID-19. So this is going to be very interesting to be on the other side of the video calls. So I'm very excited to start this. Actually, Zoom meetings, but it's the first time. So I'm actually just trying to see how I can share my screen with you. It's a little different from Teams. Let's see. Does it work now?
Yeah.
So perfect.
Now I can see that.
Okay. Wonderful. Right. Okay, so my name is Anjeli Kumari Ilieva. So a little bit about myself. I work for a medical device company in Finland called Bonalive Biomaterials. We produce bioglass, which is used as an implantable device, and it's implanted into bones, and I'll come back to that a little later. My background is I grew up in Finland. I studied and done my basic education here, after which I did my bachelor's in England, and then I came back here for my master's degree in medical imaging. And after that, I came to work in the field of medical devices because I was very interested in exploring the commercial side of science and medicine. And so today's content layout is, well, I will start by talking about antimicrobial resistance and growing resistance and potential effects of COVID-19. And I will shortly brush up on the very important topic of mental health and how it is becoming more and more relevant during stressful times like COVID-19. So what is microbial resistance, or AMR? A little history often helps to think about where we were maybe 100 years ago, in a world without antibiotics. Things that we take for granted today, back in the day, it was simply not available and wasn't discovered. And so the world in the past centuries looked very different. You could die from the simplest infections that are easily treated today. Things like pneumonia or tuberculosis were incurable diseases without antibiotics. Even the tiniest scratch, a cut, could result in blood poisoning or sepsis. And so theoretically, you could die from a scratch. So that's the kind of world our ancestors lived in. And so truly, the discovery of penicillin was groundbreaking, and it truly changed the world. And it's helping us still live longer lives because you don't die from the smallest infections. And so the 1940s, when antibiotics started to become more and more available, It was a true turning point in modern history. And during the Second World War, troops were started to being treated from infections, because you can imagine how many wounded soldiers there were during the World Wars. And of course, during the World War I, there still wasn't any antibiotics, but the Second World War, things like amputated legs that resulted often in infections could be treated. So, yeah, up until then, before antibiotics, our best treatment options was keeping our fingers crossed and hoping for the best, which wasn't always effective. So we're very thankful for the discovery. So what's it have to do with today's world? Since we have antibiotics, why do we have to worry about them? Well, as you can see in my slide here, things have changed a lot in the past decades. First of all, bacteria are evolving, mutating, and fighting back antibiotics. And this is creating resistance and to antibiotics. And so we have resistant bacteria that the antibiotics no longer work for. I want to show you a little video concerning this, because I think it really helps you visualize how bacteria overcome antibiotics. And so this is a study done, and if it loads up
So
there.
what we ended up building was basically a petri dish, except...
Can you hear the sound well? Maybe I should increase.
But it's 2 feet by 4 feet. And the way we set it up is that there are 9 bands, and at the base of each of these bands, we put a normal petri dish thick agar with different amounts of antibiotic. On the outside, there's no antibiotic. Just in from that, there's barely more than the E. coli can survive. Inside of that, there's 10 times as much, 100 times, and then finally the middle band has 1,000 times as much antibiotic. And then across the top of it, coarse and thin agar that bacteria can move around in. The background is black because there's ink in it, and the bacteria appear as white. First, you see they spread in the area where there's no antibiotic, up until the point they can no longer survive. Then a mutant appears on the right. It's resistant to the antibiotic, it spreads, until it starts to compete with other mutants around it. When these mutants hit the next boundary, they too have to pause and develop new mutations to make it into 10 times as much antibiotic. And then you see the different mutants repeat this at 100. And after about 11 days, they finally make it into 1,000 times as much antibiotic as the wild type can survive. And so we can see by this process of accumulating successive mutations that bacteria, which are normally sensitive to an antibiotic, can evolve resistance to extremely high concentrations in a short period of time.
Okay, so I hope that helped visualize the process of how bacteria evolve and become resistant to antibiotics. And so what causes this is, well, there's a lot of factors that affect the development of antibiotic resistance. I have here taken an example division of how the resistance develops in different parts of the world. So in developing countries, the key contributors identified include lack of surveillance of resistance, poor quality of available antibiotics, clinical misuse, and ease of availability of antibiotics. So what does this mean? Ease of availability means that you can buy without prescription from any pharmacy, basically. And a lot of the times we see with sort of self-help. You don't go to the doctor. You feel like you have maybe a urinary tract infection, and you're like, you know what, maybe I should get an antibiotic. And you've heard that your friend got prescribed this type of antibiotic. You call her up and you say, hey, what was the medicine that you were taking? And they tell you, and you go and you self-diagnose and self-treat, and the risk of that is, A, you don't get the right antibiotic because, not all urinary tract infections are similar. B, you might not take the correct dosage for your height and weight. You obviously, since you're not a medical professional, you might not know for how long to take it, how often to take it. And in the end, you might just treat it a little bit, enough for mutation in bacteria present to overcome the current antibiotic you're taking. And then they grow and fight back. And then you have, again, an infection. And this time you don't know what to do because the medicine that you took already has been rendered useless. So this is one example of how it can go. Clinical misuse, again, this is sort of similar, but for example, overprescription by doctors, just in case. And of course, poor availability of antibiotics. Another factor, and a huge problem, of course, is also that people don't take the whole package. When you're given, let's say, for a week antibiotic, and you take it for 3 days, and you start feeling great, and you're like, well, I don't need to take it anymore, right? And you save the rest. Well, this is one of the biggest problems we're facing, is how to make people take the whole course and don't share it with others, So this is very much regulated. For example, in Finland, you don't prescribe it to everyone, and people are reluctant to take antibiotics because they know that not everything is treated with antibiotics, which is another misconception that, my grandma used to always go direct route to antibiotics. The moment I would get a little cough, she was like, well, we have to get the drugs. And I'm like, well, we don't know. Maybe it's a virus. If it's a viral infection, antibiotics will do no good. And in those cases, you really need to let your own immune system fight for it. And taking antibiotics is not also one way street the way your immune system works, but I will leave the details for another longer talk, and I'll move on to sort of what are the problems we face in developing countries. And one of the issues is poor hospital level regulation, and another huge global issue is excessive antibiotic use in food producing animals. And so the use in meat farming industry is a huge issue, and the reason why they use so many antibiotics in the production of meat is because, well, meat production is very expensive, but the buyers, the population of humans who want to eat that meat, want to buy it cheap. Well, if you're a farmer and you need to sell cheap meat, what do? You don't have enough land to raise thousands of cows. You don't have all these pastures available. That land costs money, and so you crowd all the animals in one space. And the crowding of animals in one space is a huge problem because if one gets sick, they're all next to each other. Everyone gets sick, and then you lose all your cattle, and so then you have no meat to sell. So what do? It is to prevent infections in your animals. You give routinely, just in case, you give everyone antibiotics. And what does this lead to? Antibiotic resistance. And so you think, okay, well, the cows have developed antibiotic resistance, not humans. But there are occasionally, the disease will jump a species barrier. So it will go from an animal to a human, just like viruses do. And we're seeing it, well, today. The very reason why we are in our own homes is because a virus, a pathogen, crossed the species barrier. And this is called zoonosis. And this happens both for viruses and bacteria. And so, and in the case of COVID-19, it occurred in a wet market where it crossed that species barrier from an animal to a human. And in the case of antimicrobial resistance, this also occurs because it has, for example, in a pig farmer, its animals have been developing resistance to a drug, and then it passes on to the farmer. The farmer passes it on to his family. His kids go to school, they pass it on, and so forth. And here we have a perfect recipe for resistance to occur. And so the question might sometimes be, well, why don't we just make more antibiotics? Well, research on novel antibiotics is slowing down due to the lack of economic initiatives and antibiotic research. And the reason for this is that the moment you create an antibiotic, it starts being used and misused, and it becomes useless. It's rendered useless by its misuse in a very short amount of time. You know, you in the previous video, you saw how quickly a bacteria can mutate, and it doesn't take long for misuse to happen. And if you are a pharmaceutical company who's trying to make, you're investing loads of money into production of the treatment, antibiotic treatment, and it's rendered useless. So you have nowhere to sell it because it no longer works. So you lose money by investing something that becomes useless right away. So what can we do? We, always think about, first of all, individually, what can you do? Well, don't buy them off the counter. Rely on what your doctor tells you, what your doctor prescribes you. Take it for as long as your doctor tells you, really till the very end of your treatment. If it says 2 weeks, you take it for 2 weeks. If it says for 1 week, you take it for 1 week, or whatever. You take the exact dosage and when it's supposed to be taken. On an individual level, we can also spread knowledge about antimicrobial resistance, which is what I'm trying to do right now, and bring light to a problem that is emerging, and it will not go away unless we address it. On a global level, we should really try to reduce the overuse of antibiotics in livestock and fish farming. We should there's many ways we can go about this, but better initiatives for development of antibiotics. One of the reasons is poor infection control in hospitals and clinics, so this can be addressed as well. And on global level, supporting initiatives that help in the fight against antimicrobial resistance. But also, on the scientists' point of view, what are the scientists doing? They're not just sitting and waiting for a miracle drug to occur. It is constantly constant research is going on in this field, and I have brought here today a really nice study that looked into the clinical pipelines of drugs that are being developed by different pharmaceutical companies and medical device companies. So there has been growing interest in alternative treatments. So as I mentioned, antibiotics, they work for a while and then they stop working. So we are now looking at alternatives to antibiotics. What else can we do? How else can we fight antimicrobial resistance? And so in this field, I personally think that there's many exciting discoveries and opportunities occurring. A potential exciting future prospect is, for example, here in the right corner, we have phages. They can be used. They are used. There's been extensive studies starting on the use of them, but they're very much in the beginning still. We have antivirulence approaches. So we try to affect the environment of bacteria. If you create an unfavorable environment to the bacteria, they will die. So you're not directly affecting the bacteria by attacking its cell wall or its own replication or anything to do with the bacteria, but you change its environment to be unfavorable, and therefore you stop its replication. And then you can create antibodies, vaccines. There's been also some research done into repurposing drugs that have been FDA approved for other illnesses, but have been used for treatment of infections. And yeah, the list goes on, and this is potentially very exciting things on the horizon, but we can't just rely on new things. We really need to fix our current ways of misuse. And this is where I'm currently working, this company. And one of our products, which is granules, are used in bone infection surgery. So a common problem that you see, for example, in a patient who's been in some sort of an accident and they have an open fracture, the bone is sticking out. This is a perfect example how, the dirt gets into your wound, right? And, you try to fix you get the bones to merge together, you try to fix the problem, but the infection is already there. So you start treating with antibiotics, but the patient, because they stay for extended amount of time in a hospital, they develop antibiotic resistance, so the antibiotics no longer work. So what do you do when antibiotics don't work anymore? And so to sort of prevent this from occurring and not just having one option, we have granules that are used that can help not only in healing the bone, but the product has also been shown to inhibit bacterial growth. And when used with systemic antibiotics, I think this is a great method to treat, for example, and it's used in treatment of osteomyelitis. And so, it not only helps in the remodeling of the bone and filling of bone voids, but it also helps in inhibiting bacterial growth by creating an unfavorable environment for bacteria to grow and reproduce. So, the current COVID-19 and antibacterial microbial resistance. Well, these are just examples of news articles that are emerging. And as the situation is unfolding, we are starting to see some worrying signs that worries people involved in about antimicrobial resistance. And well, for example, here, this is a study where they looked at, it's a retrospective cohort study looking at the clinical course and mortality of inpatients with COVID-19. And interestingly, they found that half of the deceased had a secondary infection. So COVID-19 is a virus, but the half of the patients that died had a secondary bacterial infection. And so this leads to a lot of antibiotics being used in hospitals around the world. And this is, of course, creating worry. And it's a case of concern because the inappropriate use of antibiotics, again, rises as an issue. And it can further exacerbate the problem we have already at hand with the rising antimicrobial resistance. And that concludes my talk on antimicrobial resistance. I could go on for a long time on this topic, but I will move on now to the second topic, which is circulating because of the COVID-19 outbreak, and that is mental health. So we're all stressed out and stuck at home, and there's uncertainty in the world, and people are losing their jobs, and a lot of people suffer in silence. And so this is why I thought I would bring forth another very important topic in today's world, which is mental health. And it's a topic, an issue that has been stigmatized around the world. And this is why, even though I'm not by any means an expert in this field, I thought I would use this opportunity and this platform to open some discussion and just to bring it up, and maybe spread a little bit of knowledge, or the knowledge of how little we truly know, because we really don't know much. If you compare how much we know about the brain compared to other organs, our knowledge is very limited, and it has been for a very long time. And so before we start talking about mental health, we first have to understand how the human brain works. And that's the $1 million question. And whoever can come up with a definitive answer will be thanked by the world. But for now, we are just beginning to understand in the scientific world how the human brain works. There is a lot of things we don't know. We know what the connections in the brain are, right? But we don't know enough information on how, we don't have the information on how information is processed by our brains. So we know that there are connections, but how is that information, how is that input? When you receive some information, how is it processed by your brain? So how does, for example, learning and memory work? Why do we sleep and dream? These are things that people are working on, and a lot of exciting discoveries are occurring. And there are a lot of theories and ideas based on like the previous things that I mentioned. But because we know so little about the human brain, and maybe I'm underestimating how little, maybe a neuroscientist out there will tell me that they know everything. But because we don't know that much of the normal functioning of the brain, we're struggling in understanding the disruptions occurring in the brain and how they give rise to mental illnesses. So in the 1990s, fMRI imaging was developed and started to be in use. And this really, I think, in my opinion, revolutionized the way we started studying the human brain, because now we don't have to just rely on CT scans or cutting up the human brain, which really doesn't show us much. With fMRI imaging, we can look at how the different parts of the brain activate in different individuals. And so studies on fMRI have given a lot of hope into understanding better what happens in a normal brain versus what happens in a patient with, let's say, depression or post-traumatic stress disorder or anxiety or OCD, schizophrenia, you name it. All these illnesses can be now imaged, which is great, because up until now you were just labeled as a crazy person, right? Or if you had depression, you were told to just try to be happy, right? Which is kind of like telling someone with a broken foot to just try to walk without any medical intervention. And so this is showing us, for example, this is regional brain activity associated. This is a patient with schizophrenia. You look at patients. Oh, this is actually, this image here is clinical improvement in PTSD's post-traumatic stress disorder patients. This is before and after cognitive behavioral therapy. So therapy is not just talking to, having fun talking to somebody. It's actually treating your brain through talk. And I'm not going to go too much in depth in diagnosis and treatment, but other let's take, for example, type 2 diabetes. You have symptoms, you do blood tests, you get a treatment. The situation is very much different for mental illnesses. You have symptoms, and depending on the country, some countries where it's very stigmatized, you suffer in silence, and or you're labeled as crazy, and which does not solve your problem. If you're lucky enough to have people around you who are aware of mental illnesses and have it being not so stigmatized, you might have the courage to express your worries and go to a doctor, where you will talk to a psychiatrist. However, we don't have any affirmative tests to be done, so you're you're diagnosed based on what you talk about. There are tests you can do, but there are not clinical tests, let's say. And the hope is that in the future, maybe with fMRI, maybe that will be a possible sort of method of diagnosis. It's still in very infancy. We still need a lot more fMRI studies, but maybe this is something that, in the future, who knows, maybe you will first go into an MRI to see what kind of illness you've got. And maybe after therapy, you will go back and get your MRI of your brain and see if it has been effective treatment. And so this brings me back to COVID-19. There's growing stress, anxiety, and anxiety in the world. And in some people, stress affects the brain more than in others. And stress has been identified as a potential trigger for mental illness. So the more stress there is, the likelier it is for some individuals to develop anxiety disorders. It can lead to depression. The link between stress and depression has been investigated, and it's very important to understand that these kind of situations, world situations, now more than ever, we need to talk to our families, make sure they're okay, and just bring up the topic so that the people who are suffering, they know that they don't have to suffer in silence. And so what can we do is just to spread knowledge, talk about mental health, create safe spaces within your families, talk to your family members and tell them that, you don't necessarily understand mental illness, but hey, I've heard about it. Does anyone need someone to talk to? Just talk openly that you're not crazy. It's okay to not be okay. Be a good listener. Don't give medical advice unless you are a doctor. If somebody needs help, advise them to go and see a doctor, see a psychiatrist, and don't think you can fix someone's problem just by telling them that you should just be happy or just snap out of it. For example, this meme which I added because everyone has tried. Not when you tell somebody don't stress, I don't think it's a magic pill to not be stressed. So yeah, that on that note, I conclude. These are some I thought ironic and funny images of how mental health is perceived. How you would not, for example, in this case, give medical advice to someone with diabetes on what they should or should not do. So, yeah. I think that concludes my talk. Thank you very much. It has been great to be here today with you. If you have any questions, please feel free to ask me anything.
Thank you, Anjeli, for such a informative talk that you have given to us, and it was much more way higher than what we had expected. Very, very informative, of course. And yes, you were talking about, and there were so many things coming to mind. Developing countries, how we take medicine, about it, how it is in India that we take medicine over the counter. Self-medication is a new norm, has always been a norm here. And really going to the doctor, medically, if we go to the doctor only when we are expected to go to the doctor, not in general terms that we go to the doctor. So there had been, yes, it was, you have well summarized everything to the extent that it was like all the memories were coming to my mind, and all those things and all those cultural indicators are also there when we're talking about. So it's not a practice like we okay, if I'm not well, I know what antibiotic I can take. So that is not advisable, of course. And then you spoke about the developed countries, which was very, very informative again. And hopefully after COVID-19 situation, we learn our lessons well, and we should know how to deal with our health, which is secondary. And in India, you know how it is health has always been a secondary, not only for the people but also for the those who are policymakers. No? So it has always been a secondary process. Like first comes home, shelter, food. They are the prioritized and not the medical facilities. So, but still we have been able to survive this COVID-19 situation. Hope we learn our lessons well after COVID-19. And sometimes I feel that it has given a good jolt to us, and it has raised us out of a slumber. We were in a we were in a very comfort zone, so that was required. It was needed, much needed thing that it has done to us. So it was you have done a very comprehensively. You have done it, whether it is the antibiotic resistance, or you were talking about mental health and how to remain calm and poised and controlled in this pandemic, was very, very informative. Thank you, Anjali. So we will.
Thank you very much.
So